Welcome to the Regents Physics Kinematics problem set. Today we're going to talk about the solutions for numbers 28 and 29. Let's start here with 28. If you throw the ball in the previous problem up instead of down, how fast will it be moving, which implies its final velocity when it hits the sidewalk? We need to go to the previous problem to get more information. And what we have is a object, a ball, being thrown out a window 2.5 meters above sidewalk. So let's start by labeling that. The window is 2.5 meters above the sidewalk. And in this case, the ball is being thrown up instead of down. And the initial velocity, as given in problem 27, the initial velocity is 2.0 meters per second. That displacement, d, is now down, which is in the opposite direction of the direction it's thrown. We have conflicting directions, and therefore have to assign that displacement a negative value. In addition, we know that the ball is accelerating. It's accelerating due to gravity at a value of negative 9.81 meters per second squared. Again, we have to assign that a negative value because now we have conflicting directions in this problem. So any information that is up, we would call positive, and any information that is down, we will call negative. We're going to handle this problem exactly the same way that we did in the previous question, number 27. We're looking for VF. We know VI, we know A, and we know D. So it makes sense based on what's available to us in a reference table that we would use VF squared equals VI squared plus 2AD. Let's go ahead and make our substitutions. VF is what we're looking for, and it's squared. VI is 2.0 meters per second. It is also squared, plus 2 times negative 9.81 meters per second squared, times the d value, the distance, which is negative 2.5 meters. Remember that d value is displacement. It's the point of where the object ends relative to where it started from. And the object's still starting from 2.5 meters above the sidewalk, and it ends at that sidewalk. So its displacement, the point at which it ends compared to where it starts, is still 2.5 meters. We go ahead and do the algebra and solve for VF. Pause the video if you need a moment to run the calculation. And we get an answer 7.3 meters per second. What I would encourage you to do at this time is to compare this to your answer to number 27. And if this raises any eyebrows or creates a concern for you, I would ask about this in class. I'm going to ask you about that comparison between number 27 and number 28. All right, let's move on to problem 29. It says you throw a beanbag in the air and catch it 2.2 seconds later. So it looks like time. How high did it go is D, and what was its initial velocity? Of course, would be VI. Let's start with a well-labeled diagram with any information that we do know. We know that this beanbag starts upward with some initial velocity that we don't know and we're actually trying to find at some point during the problem. We know that at the peak of its flight, that the initial velocity will be, the final velocity will be 0 meters per second. We also know that it goes up in the air and comes back in 2.2 seconds. So how much time would it take to just go up? Well, it would be half that value, which would be 1.1 second. would take 1.1 seconds to slow down to a rest upward, and it would take 1.1 seconds to go from rest and come back down for a total of 2.2 seconds. We of course also know that it's accelerating due to gravity, both slowing down on the way up and speeding up on the way down at negative 9.81 meters per second squared. Now again, we have assigned g to be negative in this problem because we have conflicting directions. Our vi value is upward while our g value is always downward. And so we have to account for that, those two conflicting directions, by having positive and negative signs. All right, let's see if we can figure anything out here. We don't have to do these problems in an A-B order. It looks like we have VF, we have a T, we're looking for a VI, and we know an acceleration. So right away, it looks like we can do the solution for B by a VF equals VI plus AT calculation. So we know that the VF value is 0, VI is what we're looking for. A is negative 9.81 meters per second squared, and our T is 1.1 seconds. We go ahead and we solve for VI. Pause if you need a moment to run your calculation. And to 2 digits, we get an answer that is positive 11 meters per second. This answer is consistent with our diagram and what's happening here. We should have gotten a positive answer because that beanbag is being thrown upward against the force of gravity. Now we'll go ahead and calculate the answer to A. And let's see what we have to work with here. It looks like we're looking for D, and now we know the initial velocity, the time, the acceleration. So probably the best choice would be D equals VIT plus 1/2 AT squared. Notice I said best choice. It doesn't make it the only choice. We certainly could use other physics equations as well and still get the correct answer. This one's already isolated for D. Let's go ahead and substitute. We have 11 meters per second times 1.1 seconds plus 1/2 negative 9.81 meters per second squared times 1.1 seconds. So we have to remember to square that, the time that is. Go ahead and run this calculation. Pause if you need a moment. And your answer should turn out to be 6.1 meters to 2 digits. Okay? All right, that'll do it for these 2 problems, and more on one-dimensional kinematics vertically in class tomorrow.